Alright, we're back on part 2, and we are looking at the problem on E on our handout. I moved this work over there, so if you need it, it's still up there.
It's Friday.
Alright, I need you, Alex, to give me all the forces on this picture. And I'll put them in with blue.
Alright, first the force of the bridge on the car.
Alright, well, we don't mean the bridge on the car.
And the car
We
and the
just mean forces in general, not one on each other. So all the weights are going to cause a force. So the car you mentioned is 1, and the bridge you mentioned is 1. Alright, and what else do we see, Alex?
Pillar.
Pardon?
The pillars.
Right, and those are going to be upward as they are a supportive force, which is upward. So, is it true? Could it be that there are only 4 forces in this problem? 1, 2, 3, 4.
I just assumed that the force of the mountain holding up the bridge on the last was really minimal.
Right, exactly. Alright, so there are only 4 forces on this one. So this is going to be even quicker than the other one. So putting the forces together, the force up, pillar 1, force of pillar 1, plus force of pillar 2. Notice the other forces were downward. So 19,600 for the car, 400,000 for the bridge. And that's all. They're going to come up to 0, scratchy. Alright, switching over to the torques, each one creates a torque. So, Emily, number 1, what is the torque created by the pillar 1? We're picking an axis of rotation, you're going to have to, I was pretty wise about this, see if you were. I would pick it right here, or right here, because it zeroes out those and makes your work easier. If you picked it on the end, I actually did it, it was 3 times longer to pick it at the end, but it worked. So I did it both ways.
So you could pick an axis of rotation at any point where an upward force is established?
Right. You really don't even have to have it where a force is. You can pick it anywhere. But it's so much easier.
Yeah, that would just be.
It's just so much easier to pick it where a force is, because that will zero out, because the distance will be 0 at that point. So that's why I picked that one. So Emily, even if you didn't pick this, could you start doing the torques for me?
Yeah.
What's the torque created by pillar 1?
Is it clockwise is positive or is it negative? I always get the.
You were helping
I
me.
know,
What
now I have all this
happened?
stuff.
Now I'm getting good at it and you're failing at it. Alright, the clock is positive, clockwise.
Yeah, okay.
Alright, so here, if this was the only force on the picture, this is the point of rotation, so it's going to go this way.
So it'll be positive.
Right, so
Three.
force of pillar 1, and what's its distance? It's a little tricky to figure that out. The whole thing is 20. This is 3, and this is 3. So we want 3 and 3 is 6. So 6 from 20 should give us that distance. Did I think that out right?
Why is it 6 from?
Well, I noticed this whole thing's 20. I want this distance, right? I want the distance from the force to my axis of rotation. So if the whole thing is 20, this is 3 and this is 3, what must this be?
14.
Right. Alright, so it was a little tricky, but not undoable. Alright. Alright, Brian, help me with the car. Force of the car. I'll get the
Using
19.
the axis of rotation on the pillar, car
Right.
would just be
Yeah.
19,600 newtons times 5 meters.
5. Because this is 8 and this is 3.
Oh, so your axis of rotation is the pillar on the right.
Yeah.
Alright, not.
So this whole thing is 20. This is 8. This is 3. So what would this be? 8 and 3 are 11. So, right. 11 from 20 is 9.
I did not get that.
Alright. Just stare at it a while. You'll see that those are correct.
That's the wrong game.
Alright.
Zach,
This, alright, and Brian, is that a positive torque or a negative torque? from
Car?
a car.
I guess negative.
Right, because here's the axis, it's gonna push the thing around in this direction. So imagine it's the only force on the bridge, it would cause
wondering why they were
this
so far
movement,
apart.
which is negative, counterclockwise.
Well, the bridge itself would also cause a negative.
Yeah, but when we're doing a torque at a specific point for a specific force, we only look at that force. So you ignore the interaction of the others when you decide whether it's positive or negative. All right, Zach, do the bridge.
The bridge is 400,000 ounces times. Wait, it's negative, and then it's 3, so whole thing's 20.
Yeah, we
It's
want
10,
from here
so
to
7,
here. Here to here. He
7.
said 7.
right?
Well, half of the distance is
10
10,
minus
and
3.
then this is 3, so that's
So
It's
13.
half of 17.
So, it's,
Wait,
wouldn't
what?
be half of 17 to here, would it?
What if it's 13, then it would be 7.
Wouldn't it
It's
be
7.
7 because
Right.
you're taking
Yeah.
It is 7, but that's not half of 13.
No,
So-
yeah.
Let's say 14.
It's because it's not half of 13. It's half of 20, which is 10, subtract 3.
But the distance between the axis of rotation to the end of the bridge.
It's
It's
7.
3.
No,
So we
that's
have,
that's 17.
we're trying to get this.
No, like to the opposite end of the bridge.
Yeah, the opposite end of the bridge is 17, but we're doing the bridge. You have to do it from the middle.
Yeah, we have to do the
So
bridge
it's 10?
from the center point
7.
of mass. So that's right in the middle of the bridge.
Wait,
So what is the distance from the middle of the
Yeah,
bridge,
Brian, I was
which
doing
is
that too.
10, to this point right
I have to
here?
show my paper.
Minus
7.
Common sense
Yeah.
is
All right,
Oh.
last is this torque right here, Emily. Which torque is, what torque does that force cause?
0.
Right, because of the distance from the force to the axis, it's right on the axis of rotation. So I won't write it in because I ran out of room anyway. Equals 0. So when you tippy tap that, we get force of pillar 1. And when I did that, I got 202,600 newtons.
Yep.
And where do we go? Where in the world do we go, Emily? Number 1, to find force of pillar 2.
the equation from earlier.
Alright, so we're gonna go up here, we're gonna put force of pillar 1, we're gonna put that number in there and solve for force of pillar 2, and it came out to 207,000 newtons. Alright, do you see the repetitious nature of these? We just sort of do the same thing over and over and over, so like anything else in physics. Alright.
Line.
Alright, I'd like to, if your paper, your A, B, C, and D are all complete, I'd like to collect that. I'll give you till tomorrow to hand it in without being late. But if you have it now, I'll take it now.
Oh, main section. You, Brian,
All set?
our class is gonna be so small today. Me, you, Alex, and M-Team.
Oh,
Four.
yes.
Oh, and
Why
senior,
not?
So
senior
4.
year, since Victoria and Hunter are leaving, senior year. I think
Oh, they are?
Every day?
No, they're leaving this
No.
senior year.
Who is?
Hunter and Victoria.
I doubt Victoria is. She says she's.
No,
gonna
she
make
is. Yeah, she's
So
gonna.
that's not for sure.
That she probably will.
Hunter's
They're-
not coming
They're
back?
both already planning,
Only 5 of us?
going part-time Miller,
Well, no.
college,
Four.
or something or other.
Hunter's
Victoria
not
won't
coming?
last one name Bel Air.
Something.
Okay. Alright, interesting.
Probably like
Hey,
10 minutes or just something like that. Like,
Alright, if I do not have your A, B, C, and D, I will pick it up tomorrow. So, let's go on to our next exciting topic. And day 4. So we spent about 4 days on day 3. Let's see how long we can do day 4. Actually, this is a
Hold on.
quicker topic. It's a very classic physics topic. So take a look at what it is while I erase the board.
Wait, this one?
Up in the air right now.
Mhm.
So nothing's switching. So it'd be 5
All right, would you show the video land handout?
So, what was the first one?
Day 4.
You guys like our handout?
Yeah, that's the first one from
It's
that.
pretty spiffy.
Mhm.
Look at that. Charts.
E.
I know, but like for 1 or 2. It was like 208,000 and
What are we on for time?
You have 57 seconds.
All right, we'll shut it down now and I'll start on the next part.
Yeah, Miss Pal.